Today, Lua with Rust. Why it is awesome, and full code examples. So first, why? Sometimes we want to allow users or other developers to script our Rust application within its context. And Lua is probably the best embedded scripting engine and language out there because it's super small, efficient, relatively well-known, and battle-tested. And more importantly, it is designed and built to be embeddable. And that makes it extremely light and simple for the task. Okay, enough talking. Let's start coding. So what we're going to do here is we're going to include the mlua crate, which is the best crate to have the Lua things. Make sure you have the latest version. And then we're going to select here, you can select your Lua engine, and the good one to select to start with at least is the Lua 54. And then the vendor here, which means that it's going to be compiled and be within our binary. So usually you want that. That is to make sure that that happens in a simple manner. And then is these two things here that we're not going to use today, but that is usually what I set as well. And now the pattern that I like to do again when I learn, and I have a video about this, about the XP exploration pattern, is I have the source here, which is a lib, just a lib. In this case, it's going to be empty. And then I have my C1, chapter 01, simple. And then we're going to have multiple of those. And so the source here, we're not going to use it today. So now on this one here, I have the hello world. And what I like to do here, I have a script, which is CWE, cargo watch example. And then I just do a C1, simple. And that, we're in business. Okay, so now we are ready to do the let Lua, and that is going to be our Lua engine. So we're going to do the Lua new. That is the way we create the Lua engine. Now, if I press save, everything compiles, but there's nothing happening, obviously. Now, what we're going to do is load our first script. Yeah, so we're going to load our first script, and for that, it's called a chunk. So let's chunk, and we're going to do a Lua load. That will load our first script. We're going to put it in a multi-line, so like this. It's easier to the eye. Then we're going to do a print. So you can print within Lua, and so Lua will then print to the command line, to the terminal. So print hello from Lua. We can define a variable. The way you do that in Lua is with local, like let, and we're going to define a num, number, for example, 1, 2, 3, and then we're going to return num plus 1. So far, so good. This one is our little script here, and it should be relatively simple. So once we do that, if I toggle the type, we see that is a chunk that we get. I'm going to save this, and that should compile. We have nothing printed over there, that's fine. And now, the first one here we can do is an exec. And so to execute it, we're going to do a chunk.exec. That will return an error, obviously, and we do like that. This one has no return. I mean, it returns the error, but it doesn't return a value. So print, and then I have the hello from Lua, okay, which is this print over there. If you wanted to use a number we have there, we could do something like that. And the way you do a concatenate, do with dot dot, and num. That will work. Press save. We have hello from Lua, 1, 2, 3. So far, so good. But we don't have any value back, yeah? So if we do let result, that will be nothing, void, okay? That's one way of doing it, but it's a little bit the boring one. So the better one is to do an eval. And when we do the eval, we have a result now, and we're going to do a chunk eval, and then we can put it here, or we can use a turbofish and thing. We need to say the type that we want back. So we're going to keep it very open right now, and we're going to say value. So we're going to assume here that the function, this one, will return a value. If it doesn't return anything, we'll get null. Otherwise, we get the value here, which will be this one. That is very similar than CRD value, which is a very well-known pattern in Rust. So we have the mlua value, not CRD value, it's mlua. And then we do a question mark here, everything. And because I have the box din over there, everything works nice. I don't have to have any how and so on. So now I have this result here. I still have the print hello world over there. And then I have my little debug print that I like to have. And I'm going to do a res in debug mode. Press save, and that's it. We have the hello from Lua, which is a print that we get there. And that is a value with 1 to 4. So far, so good. Okay, so now what if we wanted to have in our script over there, we wanted to have a global value 1, for example. If we press save, that will fail. And we'll get these kind of things here where you say, hey, I don't know what is value 1. So that is what it's saying. It's saying, I don't have any global. So how can we do that? So we're not going to change this file because the way that I like it is I'm going to have this second advanced things as another example. So we're going to create the C02 scope. So we're going to take this file and we're going to duplicate it for our C02 scope. So that is what we're going to do here in this file. We don't forget to stop the terminal, and then we're going to do a CWE, same one, C02 scope. And we're back to square one. So now what we want is we want over there to have actually kind of value 1. And that will be kind of a global value again. If I press save on that, again, we'll get the same error over there. So we're not going to use the exec on this one. And so the goal is, how can we put a global value into the thing? So the first option will be with the globals. And the way it works is very simple. You have a let globals equal Lua globals. And that returns a table. And a table in Lua is everything, basically. It can be a list or it can be a dictionary, in short. So here you get a dictionary back. And then the way you set a value on that is with globals set. So there's a kind of inner mutability here. I don't need to set mute on this one, because in fact, the globals belong to the C implementation of Lua. So it's within the same process, but it's delegated. And now I can do a set. We're going to do a value 1, and we're going to do a 111, for example. And then we get the error. So once we set that, and notice here that we set it after, or we could have done it before, obviously, but when Lua parse or load the chunk here, it doesn't check. Obviously, it doesn't run the code, so it doesn't know that that is needed. It just makes sure that the syntax is okay. And then we make sure that we do that before we do the eval. So now if we press save, boom, 2, 3, 4, because we added 111 to 1, 2, 3. And that is the reason why our eval is working fine here. We do the eval, we ask value, and that is where things will have failed otherwise, but because we have done that before. Now, there's another way as well, and that is, the second option is with the set environment. And that allows us to not change the globals at the Lua level, but more to pass the environment to the chunk, such as it only get affected on this one. And the way it works here is we do a env, let's call it env equal Lua create table. So that will create a table. And by the way, that will return a result. Yeah. So in case the Lua engine doesn't work for whatever reason. So it creates a table within the Lua C code. Yeah. And then we do a env set, and we can do a value 1. We're going to do our 1, 1. If we press save here, that is going to fail again, yeah, because we didn't set it. And now what we can do is a let chunk, because it's going to consume. So it's consuming and returning it. Chunk set environment, and we're going to do our env. So this way here, we get back our chunk, and then below that will evaluate. Yeah, so that is the way it works. So this is fine because that is the same chunk that we had before. Now, if we press save here, we're going to be disappointed because it's going to fail. And the reason why is because now print is not found. Because in fact, when you set your environment variable, you actually set everything that the chunk is going to see. But the print was part of the globals, or the default globals. So what I like to do here is I get the globals, and then I'm going to iterate on the global. It's going to be more clear later. Globals, pairs, and I want value of value. So that is what I'm going to iterate on. Then I'm going to do a let key value equal pair. There are other ways of doing it, but that works well. So this one is iterator here, return a result of value. Here I make sure that I fail if it doesn't work. And then I'm going to say env set the key and then the value. Then I put that. That will add those globals on top of the environment. So if I had print here, that is going to override it, which is usually what you want. Yeah, you want the real globals to take precedence in a way. So I have this value 1 here, and I have the things. And now, if I press save, boom, everything works. We have the hello from Lua, from the print that we didn't lose, and then we had our result here, 2, 3, 4. And that is pretty cool. Okay, so what we're going to do now, we're going to do our third chapter, which is going to be about calling a Lua function. So we're going to define a Lua function over there, and the goal here will be to call it. And there's some benefits to that here, and then after it can get very powerful. So we're going to see that now. So first, let's make sure we stop the terminal, and we're going to do our CWE C03 Lua FN. And so we're back to square one. So now on this one, let's say that we want to execute this code many times. So we're going to take option 2, which is fine. And so what we want is to take all of this code over there and put it in a for loop. So what we want here is to make sure that we can iterate over there. And for example, here's a value. We're going to have something like that where we add I. Doesn't make sense, but doesn't matter. If we press save, we have a problem here where the chunk is now moved on the next loop. And the reason why is because the set environment here, if we option click on it, it consumes the self. And so that is the way when we eval a chunk, you kind of consume it. And so that is an issue here because then after on the next one, it's not available. So how can we call it without having to reparse it? Because one solution we can do is to say, okay, we're going to take this guy and we're going to put it there. And now that will work. It will give us our 3 guys over there, which is fine. But obviously, sometimes we say, well, we don't want that. We want to have a function and having Lua to do is caching and parsing everything once, and then we want to call it multiple times. That is basically the way here that Lua function, calling a Lua function can become very useful. So I'm going to put this one like that, and we actually want something like that. Yeah? But if we press save again, it will fail. So now what we can do actually is define a function. So that's a function in Lua, and we're going to call it do stuff, for example. And we're going to take a name actually. We're going to see later how we can use it. But so far, it's just going to be global values. So we're going to do that this way, and that is a syntax. It's not a space language, so you can have any spaces over there. It's just when you have function, it has to end like that. Okay. And now that, if we eval that, it will do nothing, and actually we cannot get anything back. But what we can do here is a return, and we're going to return our function. And if we had more function, what we'll do is we'll do a do stuff equal do stuff. So that will be the function, and then do more equal do more if we had another function. So that is a way that will return multiple functions. And in Lua, this is a table, and you don't do colon, you do equal. So, but for now, we're going to say that this one returns just one function, do stuff. If we press save, everything is going to break anyway. But here's a magic. The magic is the following. We're going to do a let Lua fn, okay, we're calling Lua fn, and it's going to be of type function, and we're going to do a chunk eval. And the function is obviously a Lua construct. So I still complain because we are still using the chunk below. But what it does, this one, is to say, well, I'm going to evaluate the chunk, the thing that has been parsed, and I'm going to return whatever value it is. And whatever value it is, it happened to be a function. That's why we get function here, and that will work. If we were not returning a function, here we'll get an error. But here we're going to get a function. Okay, so now we're going to close that. And what we can do now is take all of this environment business that we had. We're going to remove it from there, and we're going to add it to our function rather than adding it to our chunk. So we're going to still build the environment. And then here we're going to say a Lua fn, and that doesn't return a chunk because actually if we look at the signature of this one, it takes the reference of self. So it's a reference of function. So we're going to set it for the function, and then we're going to be able to reuse the function across the loop. So what we're going to do here is the Lua fn, and then rather to do that, we're going to do Lua fn, and then we're going to do call. So that is a way you call a function. Yeah, you don't eval it. And in a call here, there's an argument, which is the into Lua multi, which is a trait, which does the Lua multi kind of things. So if we option click there, this is a multi value. We're going to take that, and we're going to do a let args, and then we do a new like that. Make sure to import it, and then we're going to take that and put it there. Now we're calling the method. Press save, and we get our result back. And so that is pretty cool. So what we have seen here is we have created a chunk, which is basically our script, which happened to return a function. And then once we get the function, we can actually set the environment, which is a scope, the global scope here. And then we're making sure that we're adding the globals as well. And then we set the environment for the function, and then we can call the same function with different arguments. And right now, the argument is empty. But if we look at our code over there, we can see that we have the name, and we had this coalescing here. So how do we pass name? Super simple. We already did half of the work. We go there, and this one here needs to be a mute, because actually that is a value of Rust, which then becomes a Lua value. So we respect the Rust way, and then we do an arg, and then we're going to do a push. We're going to take the push from, and we're going to take Rust, for example. And that is where we need to make it into the Lua world. So into Lua and the Lua. Make sure you make the question mark, save, and then boom, we have the hello from Rust. And that is pretty cool here. So now we have the chunk here, the script that return a function, which is fully reusable, and then we can use it in our for loop over there. And if we wanted here, we could even do something like that. I mean, here it wouldn't make sense here, but fn equal Lua fn clone, that does a clone. So here it still works, it doesn't make sense, don't do that. But if you wanted to send that to multiple thread or async task and everything, if you have the right features, you could do that, and that will work beautifully. And this is awesome. And the mLua ergonomics is very nicely designed, so great job on them. Okay, so now we stop the terminal, and now we want Lua to be able to call a function that we have defined in Rust. So we're going to do our C04 over there, and that is this file here, which I already prepped a little bit. So the first one here is we have our Lua, as before, and right now we have a mock, in a way, script, where we have the local num, the stuff that eventually we're going to call our function, and then the sum, where we're going to call our function with 2 arguments, and then I print everything here to make sure that we see how it looks. And then on this one, very simple, I'm just doing a res and an eval, and it's just to see the result. So that is very simple. And then our goal here is we're going to create this function, and then that function. So if we do a CWE, C04, Rust FN, we get 1, 2, 3, this guy, the 0, this guy, the 0, this guy. So all good. So in Lua, we can put a function at the root if we want, obviously, or we can put it or namespace them into a util. So that is usually what I like to do. And so in Lua, this utils is again a table. So we're going to create our utils Lua module, and that is going to be a utils Lua create table. And it can fail if something happened at the C level. And then the only thing you do to make it as part of the thing is we're going to have in the globals, you do a Lua globals, which is a table, and then you set the utils, and then our utils. So that is a util, a table, and this one we set them. So if we press save, everything works, but obviously we have nothing in the scope, yeah? So if we are going to uncomment this one, press save, then kaboom. Yeah? So we're going to leave it like that for now. So the first way to create a function is with a closure. So we're going to let compute stuff fn. So that's just a convention here. You can name it the way you want, obviously. And Lua, and we do the create function. That is what is important. And then that will take a closure with 2 arguments. The first one is a Lua, which is going to be type of reference of Lua. And the second one here will be our argument that we want to take, the first one. So in fact, it can be either a tuple if you have multiple arguments, or it can be one value if it's only one argument that you are taking. So for this one, we're going to do an arg0, and then we're going to put i64. So the Lua engine will make sure, to make sure that it's a i64 kind of type, or something that can go into i64. And then on this one, we're just going to be very silly. We're just going to do the arg0 multiplied by 2. And so that the goal here is we have that back. Now, what that takes is a Lua result with a value. So what we want to do, or with a multiple value, but a value will be fine. We're going to do a res, which is our, i64, res for results. You can name it the way you want. And you do a into Lua. So the same thing that we had before, and you give the Lua engine. Because again, the value has to be injected into the Lua engine. And that returns a result of value. And so everything goes. And that is the MLUI result. So everything is fine. So now if I press save here, that is created, it compiles and everything. But I didn't put it in the utils yet. This is not there yet. So what I need to do now is utils set, and I will do a compute stuff. And that is where I will put this function. So make sure you have that over there, such as you have the function there, and that will be like that. So now I have this there in the utils, and I put the utils over there, so I press save. There's nothing will change because we didn't change our script. And now if we go there, we do that, we'll have a 2000, which is this guy. So that's pretty cool. So that is the first example with one argument and a closure. So usually I don't really have closure. I have function, and the signature of the function, we're going to see that. Let's say that we're going to do the other one, which is the add stuff. And so this one, we're going to see also with multiple arguments. So we still have the Lua with the Lua reference, and then we want to have multiple arguments. So in this case, it's add stuff. So we're going to have the num left and the num right, but we have to put them in a tuple. So the way it works is like that, num left, num right. That is a way that we type a tuple in a function. And so the good things here is we destructure it, such as in the code, we don't have to do that. This one is going to take a I64, for example, and then it's going to return MLUA result of value. And then within this function, we're going to compute the result, which is going to be that. And now we want to turn it into a Lua value. And so that is I64. And so we do the res into Lua. And that will return a result, which is a MLUA result. So we're all good. So press save. That will compile, but we don't show it yet. And the way we are going to do that is we can set it directly over there. Typically, I do a little space over there, and then I do utils set. I'm going to have the function like that, and then Lua create function, same one as above, but now rather to give the closure, we give the function. We don't forget the question mark. That has a question mark too. Press save, and now we should be able to remove that. And that should be a 40,000. And that's it. And that will conclude our introduction of Lua with Rust. Hope you liked it. Like and subscribe. Really appreciate it. Big thanks to Nebula for their sponsorship. Big thanks to my consulting company, Bryce Snow, Architecture as a Service. Until next one, happy coding.